Okay, we are live now, Dato.
Yeah, thank you. A very good evening and a very warm welcome to Dr. Chong Hon Yu,
Good.
President of the Astronomical Society of Penang, and fellow enthusiasts. Welcome to the webinar on Lunar Eclipse from the AIMST University. Allow me at the outset to thank Senior Professor Dr. Ravi Chandran Manikam, Dean of the Faculty of Applied Sciences, and Dr. Hari Prasad, Dean of the Faculty of Engineering, who are co-hosting this webinar. And without their involvement and active pursuit of this show today and webinar, we would not have this. And of course, the man of the hour is Dr. Chong Hon Yu himself. Allow me, sir, to explain in a few words the purpose of this webinar today. Of course, number one, it is to excite an interest in astronomy, and I'm happy that my daughter, Pamela Asha, is with me, and I hope that she will gain an interest and pursue this interest in astronomy further, just as I would exhort all of us today to, based on your excellent exposition, carry on this interest and this flame of getting curious on astronomy after this show. The main purpose then, of course, is apart from this cultivating this interest, we also want to bring cheer to our students who are all holed up in their hostels given the COVID. And we hope that they will enjoy this webinar with Dr. Chong Hon Yu. I would do no justice if I do not introduce Dr. Chong Yon Yu, the President of Astronomical Society of Penang, to our fellow viewers and participants in this webinar. Of course, he has an illustrious career. He is a retired physics professor from the University of Science Malaysia, Penang. He is the founder and current president of the Astronomical Society of Penang. He received his PhD in 1979 from the Université de Grenoble, France, with specialization in low temperature, solid state physics. But perhaps Dr. Chong is better known as one of Malaysia's top astronomy popularizers and a passionate teacher of astronomy. He joined the USM as a lecturer in 1979 and founded the USM Astronomy Club in 1986, subsequently inspiring astronomy enthusiasts in Malaysia through public outreach in events, including webinars like this and activities in schools at all levels. Since his retirement from USM in 2015, he has proceeded to establish the Astronomical Society of Penang in 2016 and has served as the organization's president until today. Through his continuous efforts, astronomical outreach activities, and the spreading of astronomical awareness to the masses is going full steam across the country and beyond the shores of Malaysia. And his dedication and his quote for us today is, "Seeing is believing, doing is fun, and open your hearts to the universe." With this, I invite, on behalf of all of us, Dr. Chong Hon Yu to share with us his thoughts on today's auspicious moment of the lunar eclipse. Dr. Chong, the floor is yours.
Thank you very much, Dato Professor, Dr. What they call John Anthony Xavier, for your very generous introduction. All right. So
Welcome, sir.
yeah. So I hope that after this webinar and so on, AIMS also will proceed to continue to instill in your student and your staff that astronomy, some or other, is actually related to many of the studies in your university. All the sciences, physics, chemistry, mathematics, engineering, definitely. All right. So, and I would like to thank, of course, Professor Manikam Ravi Chandran for giving me the opportunity to give this talk. Nice to see you again, Professor Ravi Chandran. All right. So, and the staff of this AIMST University. So, maybe you can allow me to start my talk now. All right. I share. Is it okay? I share now?
Yes, yes, sir. Please do, sir.
I share. Okay. Can you see my screen now?
Yes, sir.
Can you see my screen now?
Yes, sir. Yes, sir.
Yeah.
Yeah.
Okay. So the title is wait, let me hide the thing, hide notification. Okay. Lunar eclipse of 26 May 2021 as seen from AIMST University. Now, some of you may say, I thought tonight is a total lunar eclipse. And some people say from Malaysia it's a partial lunar eclipse. So which is correct? So is it a lunar eclipse or total lunar eclipse or partial lunar eclipse? So I will clarify later. All right. So basically, tonight is a big day. So as I'm speaking now, Professor Dato, Professor Ravichandran, thousands of people all across the Pacific Rim countries are waiting and waiting. All right. So for us in AIMST University, what time? 7:30 p.m. Another what they call 1 o'clock from 1 o'clock from now. Okay. So this is a total lunar eclipse. So what happened is the moon will enter into the Earth's full shadow, umbra. Ladies and gentlemen, do you know that every moment as I'm speaking, the moon travels very fast, you know. Another name for I've been giving talks to many people in Malaysia. You know what I call the moon? The moon is a super bullet. The moon travels as fast as the bullet, you know, 1 kilometer per second, 3,000 kilometers per hour. So you're looking at a super bullet. So the super bullet moves fast, enters the Earth's shadow, then becomes a total lunar eclipse into the umbra of the Earth. Now, we also have tonight, it's called a super blood red moon. So I explain in detail why you call it super.
I want to see if you want.
Yeah. Why red moon?
Don't see the
I explain one by one later on. Okay. So basically, our Astronomical Society of Penang was formed in 2016, and many of our members are from Penang, but we also have associate members from other states. All right. So it's our sometimes called the super flower blood red moon or blood moon. Why is it called the flower moon? Because this is in a sense following the Marshalli. So in America, they have what's called the Farmer's Almanac. Almanac means long before internet came in the 17th century, 18th century, 19th century in America, they published the Farmer's Almanac. So when is the time to plant the crop? So during the month of May, when the flowers bloom, right? The first full moon of May is called the flower moon. So that's why it's called the flower blood moon. So in Malaysia, we don't use this flower so often. So for us, we call it the super blood moon. But everywhere in the world, they call it the super flower blood moon. All right. Why is it blood moon? I'll explain later. So the moon's perigee happened earlier this morning, Malaysian time, that 9:21. What's the perigee? Now remember, ladies and gentlemen, the moon does not orbit the Earth in a pure circle. So it moves in an ellipse around the Earth. So sometimes if we closer to the Earth, the moon closer, so it's called perigee. Sometimes when the moon is further from the Earth, called apogee. So perigee was this morning, and full moon is upwards at 7:30. So that's why it's a super red, super moon eclipse. All right, because it's at perigee, the moon is bigger than usual, and it's a full moon, but you have a total lunar eclipse. Okay, so this is what happened is in the center is the Earth, and then here on the left is the moon is closer, so called perigee, and further on the right is furthest away, it's called apogee. All right, so it moves around. Of course, the shape of this ellipse is highly exaggerated. The difference is not so big, but there is a difference. So perigee, moon very close to the Earth, apogee far away from the Earth. All right, so tonight will be perigee moon, super red flower blood moon. So for AIMST University, and mostly in the northern region of West Malaysia, the moon will rise upwards at 7:27 p.m. to be accurate, but roughly about 7:30, and it's already in full eclipse. Sorry, ladies and gentlemen, the first half of the eclipse where the moon enters the penumbra, and from the penumbra it goes into the umbra. That part we don't see. The first half we don't see. We are seeing the second half. Yeah, imagine you're watching a movie. You enter the movie at in the middle of the movie and see the second half. That's what I see. So now at 7:30, it's already full eclipse, and after that, the moon will be in the Earth's full shadow, red color, umbra. The moon will move from the umbra to the penumbra, and then the moon will move from the penumbra into empty space where there's no more Earth shadow. So that's it. So the whole eclipse is basically from 7:30 p.m. to 10 p.m., 2.5 hours. But when the moon is leaving the penumbra from 7:30 to about 9 p.m. So for about 1.5 hours, from 7:30 p.m. to 9 p.m., we can see the moon part of it still in the umbra of the Earth. That means the part of the moon in the umbra, what? That's funny red color. Why is it red color? We explain, right? So it's called the supermoon, means it's a full moon plus perigee. Now, so many people are not familiar that. Do you know that you have a full moon and a new moon? New moon means the full moon means the sun, the earth, and the moon aligned in a line. A new moon means the sun, the moon, and the earth aligned in a line. So you can also have a super moon during perigee, all right? But it's a new moon. But there are not many people who know, because that is what they call new moon we don't see. So more people are familiar with the super moon during the full moon. But you can have also super moon during new moon perigee, all right? And it's called the perigee. Sorry, ladies and gentlemen, it's a big technical called the CZG. So what is the CZG? On the left is the sun. Now the earth is here, and at the bottom is the moon. So the sun, earth, and moon align in a straight line. It's called the CZG. So we are in a CZG, all right, technical term, all right. So it's a perigee CZG super moon, all right. Now what about the other case where the moon is very far away from the earth? It's at apogee in a line, all right. So that will be called the apogee CZG. That means the moon is very far away from the earth, very small. So in that case, it's called the what? The micro moon. You're not familiar. You only know about super moon. It's a micro moon. The moon is far away from the earth, and there will be small, and that is called the micro moon. And by the way, the term micro moon and super moon are not accepted by professional astronomers. It's actually promoted by one of the American, not really an astronomer, such a kind of a writer on astronomy, but it's not a professional astronomer. So most astronomers do not accept the term supermoon, micromoon. So supermoon, micromoon is actually only in the public consciousness, not in the. You look at the technical scientific journal, you don't see supermoon, you don't see micromoon. All right. So the Earth-Moon distance at perigee this morning was very close, 357,000 kilometers. The average Earth-Moon distance is about 384,000 kilometers. So this is very close. The moon is very close, right? So that means the moon will appear bigger during tonight's lunar eclipse, bigger. Okay, so now it's being recorded. Continue. So average Earth-Moon distance 384,500 kilometer, and this what happened is, so the eclipse will start on the right, where you see two circles here. This circle is the Earth's umbra. Now, ladies and gentlemen, do you know that every time when the sky is clear at night, and my house in Jalan Masjid Negeri in Penang, I look at the sky. Oh, so nice! The stars are there, and the moon is in one corner of the sky. I can see that the Earth has a long shadow passing by the Earth and going straight into space to the distance of the moon. So the Earth's umbra is like a cone from the Earth to about further than 384,000 kilometers. So it's like a cone. So there are two shadows. The smaller one is called the umbra, and the bigger one here is the penumbra. So it's about more than 500,000 kilometers into space, the Earth shadow. And the moon will be, allow me, on the right, it will move, at very fast speed, So when it enters the penumbra, many people will say, Dr. Chong, when I look at the penumbral lunar eclipse, there's nothing. I fully agree. During a penumbral phase of the eclipse, there's nothing. The moon just slightly dimmer. You don't see the difference. The real fun begins like here. The moon, part of it enters into the umbra. Hey, funny, the red color. The other part is in the penumbra, still white color. But the moon enters completely into the Earth's umbra. Then the whole moon becomes red, the blood red moon. And then the moon will slowly leave the umbra into the penumbra and finally go into the empty space again. So this is the whole eclipse, total lunar eclipse, but we are able to see only from the center part to the left. The right part here to the center we don't see, right? So as I'm speaking earlier, the moon will enter into the Earth's penumbra about 4 p.m. this afternoon. 4 p.m. already, the moon passed already. But it's only around here, when it enters the umbra, all right, that you can see more. So when will the moon enter into the umbra? 7:11 p.m. At 7:11 p.m., the moon will pass here and slowly enter into the umbra. So from here to here is the best time to see the eclipse. I'll give the detail later. Okay. So the moon and the sun now is actually going to have a rendezvous. What do you mean a rendezvous? When the moon enters the Earth's shadow, all right? So the Earth and moon and sun will be in the CGG alignment. So that time the moon is in the constellation of Scorpio, the Scorpion. So this is an animation of the Scorpius constellation. It's a very prominent constellation. Anywhere in the world, even in the highly polluted area called the Klang Valley, if the sky is clear, you can see Scorpio. There you are, the 3 stars on top of the head. Then the long neck, where you have a red supergiant star called Antares, and the long tail, that's Scorpio. But this is not a real photo. This is a real photo. Some of our amateur astronomers in Bali Pulau, and we have been to other places in Malaysia, have taken pictures of this is the Milky Way, as beautiful as this. So this is the Milky Way, the plane of the Milky Way, and you see Scorpio there. So basically, the moon will be in Scorpio, somewhere here, all right? And if we wait another month, the moon will move back further to the left to where? Sagittarius. So every month, the sun will change its constellation by 1 constellation, and the moon also will change, all right? So the moon will be in Scorpio tonight. So now is just a brief explanation of where to observe from AIMST University. And at the end of the talk, I'll give you more detail. So where to observe? Here. Now you are aware, ladies and gentlemen, that this is a picture from the Google map of AIMST University. And this is in the big circle here. Is most of your departments are here. And of course, on the top right hand corner, northeast is your staff apartments. So here is in here, there you are. So here is the main complex. I see here CIMB ATM. And you have a road right from west to east. I remember when we gave a talk, Professor Ravi Chandran last time, we came up to look at the sun here. So in other words, we go back again. So especially to the right side here, all right, to the right side, facing the east, is the best place to observe tonight. So Dr. Hari informed me that there are a few students, they have a telescope, they will observe. So I would say the best place to observe is in this road, or maybe on the eastern side of this road, to observe the eclipse. So we hope the weather will be good, clear tonight. So the best website is, of course, our famous Fred Espenex NASA Eclipse website. This is the best one, good detail, all right? There are many websites now, but I still feel this is the best, all right? So it's from here, I get my data. So basically, the moon, the total lunar eclipse will occur here, all right? So now this is from the eclipse page from Fred Espenex. I will explain in detail what it means today. So basically, they'll give the information of main information of the eclipse, and there you are. The moon will enter into the Earth shadow along the northern side. Unfortunately, you look here, the moon enters and touches the top part of the umbra and come out again. If only the moon goes right to the center, then cut to the center, then the total part of the lunar eclipse will be longer, much longer. And we have seen it in Penang before. We are lucky the moon goes to the center. But even then, the moon enters into the umbra for a short while. The full moon will be in the Earth's umbra for about 14.5 minutes only. So the total phase of the lunar eclipse will be 14.5 minutes. But that's good enough. All right. So that's it. Now here below here, I'll give you more detail later. The locations in the world where you can see this lunar eclipse. So depending on where you are, some parts of the world like Malaysia, partial lunar eclipse, because we only see the second half of it. Certain parts of the world like Hawaii, the whole eclipse, total lunar eclipse, all right? So there's a bit more information here. I'll give in detail later. So for example, what we know is right now as I'm speaking, the moon already entered into the Earth's penumbra already. But at 11 p.m., the moon will enter fully into the Earth's umbra, become red. So from 7:11 p.m. to 7:25 p.m., the moon will be fully eclipsed. All right, total lunar eclipse, which we cannot see. 7:25, the total phase is over. But when will the moon arise in the east in AIMST University? 7:27. We missed the total eclipse by 2 minutes only. So if you want to see where's a good place, the further east, the better. You go Kuantan, you go Kuching, the best is of course Sabah. All right. So that's it. So this is the whole eclipse. So now you look at this thing here. So the dark part here is where you cannot see. It cannot see doesn't mean that it's day or night. It means you cannot see. The bright part is where you can see. So here we are here in Malaysia, it says eclipse at moonrise, visible at moonrise. So Malaysia not bad. India you can see, but only for a short time. But Malaysia we can see the best is Sabah and Sarawak better. But you can see the whole eclipse where you are. You see the eastern part of Australia, all right, and then Japan, whole of New Zealand, and somewhere in the Pacific Ocean, Hawaii. So I will call this the Pacific Ocean total lunar eclipse. Of course, Western North America, which is Western USA and Canada can see, and Western South America can see, right? So this is another one. This is daytime. Right now, as I'm speaking, this is daytime in the world. So daytime in Africa and so on. But the dark sky, dark ones are the one on the left and right. So we are now in the dark part. So the dark part here are where you can see the lunar eclipse. So the best place is right in the center here, Hawaii, all right? The whole eclipse can be seen from beginning to end. Australia can be seen, New Zealand can be seen, and also Japan also can be seen, right? So now we are looking at our country again. So you see West Malaysia here. We are now in AIMST, just next to a town called Sungai Patani. So not bad. We can see the what they call half of the eclipse when the moon leaves the umbra just to go into the penumbra until the end of the eclipse. So not bad. But the further east, the better. For example, you go here, the best place in Malaysia to look are in Sabah, the most eastern part of Malaysia. Where is it? Sandakan, Lahad Datu, Semporna. Now these are the places you have. Your friend in Philippines better. So if you have friends in Japan, Australia, New Zealand, New Guinea, there's a place called Port Moresby, New Guinea. Please inform them to see. All right, they can see it. So now we go and look at this. So this is a bit more technical. So for most people, when you look at the eclipse information, somewhere on top here, they will say Saros cycle. So many people are not aware. So ladies and gentlemen, I'm not trying to make our life complicated. If you want to know more about tonight's total lunar eclipse, I say that this is the total lunar eclipse of the Saros series, number 121. And it is number 56 of 84. So that means there are many types of Saros series. I'll explain later. And this Saros series, number 121, there are 84 lunar eclipses in this series. And tonight's one is number 56 out of the 84 in series 121. Well, how come it's so complicated? It can be explained. So a Saros is a period of exactly 2 to 3 synodic months. So ladies and gentlemen, do you know that when we learn astronomy, in a sense, after some time, do you know what we become? We become an expert in calendar, in the Chinese calendar, Hindu calendar, in the Muslim calendar, all types of calendar. Study of calendar is very complicated, no? So this is, a Saros is a period of exactly 226 synodic months. So synodic month means a time, let's say you see tonight is the full moon, and then you wait for another month later when it's another full moon. So that period from tonight's full moon to the next full moon is called a synodic month, right? So many years ago, the astronomers in the Middle East already know that a synodic month is exactly equal to 6,583.3211 days. Plus, and this is equal to 18 years or 10 days, or 18 years or 11 days, or 18 years and 12 days. And this is actually, the first Saros was used by the astronomers in the Neo-Babylonian Empire. So ladies and gentlemen, so when we learn astronomy, so what did we learn? History. The history of all the ancient civilization and even in the modern civilization. So you have to become a kind of an expert in history, you know. So basically, we know that there's an ancient civilization in Mesopotamia, right? And the Mesopotamian Empire, you have the first Babylonian Empire, second Babylonian Empire, and this is the new Babylonian Empire. Sometime in the first millennium BC, right? That means about 600 years BC that time, in a place in Babylon, which is part of the Mesopotamian area, the what they call the astronomers already knew about the Saros cycle. For example, you have this astronomer at that time were looking and recording. So you'll be surprised, you know. I'm always in admiration of this astronomer because during that time, Isaac Newton was not there. Isaac Newton was in the 17th century AD. So that time was 6th century BC. They already knew the solar cycle without knowledge of calculus, without knowledge of the what I call this law of gravity, and they were able to predict solar and lunar eclipses accurately. And we know that in many civilizations, even the Middle East civilization, like the Babylonian civilization, the knowledge of astronomy is actually in the hands of the priesthood, the priest. So the priest will learn about that, they'll pass to their children, and the knowledge will pass to the grandchildren and great-great-grandchildren. It's held by the priest. So the Babylonian astronomers were the one who knew about the stars. So they could predict stars very accurately. So I'm very amazed by that. No? 600 years BC, all right? Star series was already discovered. So we are now in Star series number 121, all right? And this is the 54th of the 84th, what I call thing. So this is Star series number 121, and in series number 121 there are 84 lunar eclipses, and tonight one is number 56 of 84. So you ask me, how long does this Star series stretch? Huh? From the first to the 80th, maybe 1 to 2,000 years. So now they can predict the Star series 121 for 2,000 years. What about the Star series 122? It will overlap with the Star series 122 will overlap with Star series 121, and again each series will be over about 1 to 2,000 years. So you can imagine those ancient astronomers are so advanced, you know. All right. So this is what happened is you have here in the center is the Earth's umbra, shadow in space, and here there's a penumbra which you don't see so well, and here there's no shadow of the Earth. So the moon will move very fast and cross the penumbra first, enter the umbra, leave the umbra, enter the penumbra, and leave. So when at 7:30, we will here, all right, here. So the moon will rise in the east, 7:27 in Scorpio, and it will look like that. So this is my simulation from my Plagium software. So imagine at 7:30, we go to the outside. There's a place where the road, I understand, is next to your library, in the AIMST University. So you look at the east. Imagine there's a clear sky. The east is somewhere in the center here with the letter E, and the moon will rise to the right of east. All right, the moon will just rise. So the moon will not rise tonight exactly at east. It will rise to the right of the moon, of the east. How much? I'll let you know. So the moon will rise with an azimuth angle of 111 degrees. Never mind. So in astronomy, we use types of measurement. This is called the local coordinate system. So azimuth angle, meaning like this. So imagine I'm standing in the center, the red dot. I have a compass to point north. So that is 0 degrees azimuth. So I will move towards the northeast. So from me to the northeast is 45 degrees azimuth. To the east is 90 degrees azimuth. To the south is 180 degrees. West is 270. Go back to the north, 360. So 111 degrees is go to the east and go down here 90 degrees, add another 21 degrees. So a bit like towards the southeast, not exactly southeast. Southeast is 135 degrees. So a bit south from the east, right? So the moon will rise with an angle of 21 degrees south of east. Dr. Hari, can you hear me also?
Yes,
Yeah,
yes.
okay,
So
so
I'm following up.
just to make sure. So the moon will rise with an angle of 21 degrees. So afterwards, I understand Dr. Hari informed me 5 of the students with 1 telescope will go out. They say, how come you look at the east, the moon? No, to the right of the east. Look at the right of the east. Yeah.
Right of the east. Okay.
There you are. Don't know it. Right of the east, another south, 21 degrees. There you're going to rise. And hope, no clouds, and so on. Okay. So now, so the correct thing is to show the eclipse, ladies and gentlemen, is just now I presented the way that the moon moves from the right to the left is wrong. The correct way to present is you rotate the picture earlier, what they call anti-clockwise by 90 degrees. So I rotated it. So in other words, the moon will enter the Earth penumbra and leave here. This is the way you should present it. Okay. So now I present. So now at 7:27, hopefully the sky is clear in the east. Then when the moon comes out, hey, the moon is already in eclipse, full eclipse. Then after the moon comes up, already in eclipse. Then the moon is not this so long. This big round dot is the Earth shadow. The moon is here. This one. Okay. So a bit later, the moon rises in the east. Rises some more. All right. So this is the situation is like this. So it rise up, all right? This is what we're going to see in the eastern sky, all right? Azimuth 111 degrees, all right? So this is how you should see, all right? So of course, if the moon is not risen from the eastern horizon, like we have done in Penang many times, we stretch our head, where? This part of the east. But once the moon come out, just about a small part of it comes out, everyone can see it already, all right? So this is moon very high, okay, go up. Okay, this is called, ladies and gentlemen, I hope out of your 5 students now, Dr. Hari, one of them may be good in photography. Do a picture like this called a time-lapse. Now, this is the place.
Time-lapse, huh?
This is not our eclipse today. This is earlier, some years ago, somewhere in the world, some amateur astronomers took this actual total lunar eclipse, where as the moon rose, all right, from the lower left to go to the right, the full phase of the eclipse. So the total eclipse is somewhere here. So in other words, you have exposed the eclipse when it's here, then maybe about 10 minutes later, take another one, every 10 minutes, many minutes later, a few hours, join them as one. So it's got a time lapse, very nice. But as I said, sorry, gentlemen, ladies and gentlemen, we cannot see all. We can only see like that only. The beginning part we don't see. Only the second half we can see. But not bad. So maybe you can tell some of the students don't have a good camera in mind. You remember, I will show you later, you have a handphone holder. Remember? A small tripod that can hold a handphone, and you put the tripod on the table on top of a car. Don't move the handphone. Keep on snapping the picture every 5-10 minutes and join them into a time lapse. And don't only, Dr. Hari, don't tell them just do like that. With a background building, a tree, right? Your university library building or whatever building like that. Time lapse with a landmark, all right? That can be done, okay? So now we can ask ourselves, what is happening? The eclipse happened because the moon is orbiting the earth. If the moon doesn't move, the earth doesn't move, the sun doesn't move, there's no eclipse. Because the moon orbiting the earth. The moon enters into the earth's shadow. That's why we have an eclipse. So how fast is the moon orbiting? Be surprised, 1 kilometer per second. I never say per hour, per second. Or 3,600 kilometers per hour. Or Mach 3. 3 times supersonic speed, you know. So the moon is actually traveling in space like our Sukhoi fighter jet, you know. Malaysia got a Sukhoi fighter jet, Mach 3. So the moon is moving very fast. Don't play with the moon. All right, very fast. Okay. So it's the speed of a bullet. 1 kilometer per second, speed of a bullet. 1 kilometer per second. 3,000 kilometers per hour. So here in the center is the Earth, and you see the moon orbiting the Earth. So basically, I will call the moon a super bullet. The moon is huge. So if ever the moon is orbiting around the Earth, and you are an alien spacecraft, let's say you park in front of the moon, let's say the moon is moving. And let's say, imagine the spacecraft parked in front of the moon, the spacecraft is not moving, only the moon is moving. Even then, the moon will crash in the spacecraft 1 kilometer per second. So don't play the moon is a super bullet. So imagine one day, this is of course taken in North America, imagine one day you go to KLCC, Twin Tower, or anywhere in your house, you see the moon rising above your house, beautiful moon. You tell yourself, don't play with the moon, it's a super bullet. But luckily, it's nearly 400,000 kilometers from the Earth. That's why you don't see the motion. It moves slowly because so far away. Actually, it's very fast. The moon is a super bullet. So I will add on to this. I think nobody in the world add on, but this is my term. What we observe tonight is a super bullet, super flower, blood moon. Why is this super bullet? Very fast, the moon. And why is it super? Because it's a huge bullet. The moon is so big. Why super blood moon? Because it's a super moon. The moon is very big, perigee. Why flower moon? Because in the month of May, in America, the old farmers who call it the full moon of May to call the flower moon. Why blood moon? I'll explain later. Why the moon blood, red color, I explain. All right. So also, how fast is the Earth rotating on its axis? Now, when you see the moon rising in the east, there are two motions involved. One is the moon's orbit around the Earth. The other one is the Earth rotating on its axis. But these two motions must be taken into account. So Earth rotates on the axis 1,600 kilometers per hour. And that's what Mach 1, you know. As the Earth rotates from west to east, it's faster than the speed of sound, Mach 1, you know. So ladies and gentlemen, next time you sit in your room, One of our students says, sir, why you sit in your room, come and join me to play football on the field? Why you don't run? You say, as I'm sitting in my office, I'm actually traveling at the speed of Mach 1. You know that? You're all traveling towards the east at Mach 1 speed. So the moon's motion is from west to east, 3,600 kilometers per hour. And the Earth's rotation is also from west to east at 1,600 kilometers per hour. So if you want to look at a beautiful picture of the rising moon in the east, you must bear in mind two things. First of all, this is the east. So the moon keep on rising, rising, rising. Why does the moon rise? Because the Earth's rotation. Earth's rotation from west to east will make the moon rise from the east and set in the west. Earth's rotation. But at the same time, if you are to observe the moon over a few hours, the moon also, the Earth's rotation will make the moon rise up, go up. But the moon's orbit around the Earth will make the moon go down. So there are two motions, The Earth's rotation will make the moon go up faster, but the moon's orbit around the Earth will make the moon go down. That must be taken into. So what makes the lunar eclipse occur is not the Earth motion make the moon go up. It's not that. It's the moon going down that enters the Earth's shadow. That is the part of the moon's motion that caused the lunar eclipse. All right. So now, is that all? No. Now this one has nothing to do with our eclipse, but I have to make the picture complete because you say the moon is orbiting around the Earth, all right, and the Earth also rotates on axis. Are there other motions involved? Yes. The Earth-Moon system also orbits the Sun. All right. So question: how fast is the Earth-Moon system orbit the Sun? The answer is 30 kilometers per second. Wow, 30 times the speed of a bullet. All right. That means 108,000 kilometers per hour. So if you sit on your chair now on a place called Earth, do you know that you are sitting on a super bullet called the Earth, traveling at 30 times the speed of a bullet? Right? But anyway, this motion of the Earth-Moon system around the Sun does not take part in the lunar eclipse. So the lunar eclipse only got two things: orbit of the moon around the Earth and rotation of the Earth on its axis. All right. So that's it. So what happens during a total lunar eclipse is this. Now I hope I have time to finish. 7:07. Okay. So basically, you have here on the left the Sun, in the center of the Earth. The Earth has two shadows: the full shadow umbra, the partial shadow penumbra. So the moon will move into the Earth. So ladies and gentlemen, we must remember that we are looking down to this Earth, Sun-Earth system from the polar axis, from Polaris, northern star, looking down. So the Sun will rotate anti-clockwise. So the Earth will rotate anti-clockwise, and the Earth will orbit the Sun anti-clockwise. And the Moon will rotate anti-clockwise, and the Moon will orbit the Earth anti-clockwise. And the Earth-Moon system will move around the Sun anti-clockwise. Everything is anti-clockwise from the north looking down. So as this happens, the Moon now is entering into the Earth penumbra lunar eclipse, nothing spectacular. Enter the umbra, total lunar eclipse, the blood red moon. Then go into the penumbra and out. So that's what happened tonight. So you see here from the right to the left. But what we are seeing tonight is basically from the center part, the full eclipse part, to the penumbral part and out. All right. So we're seeing the second half. All right. So for us, tonight's event is a partial lunar eclipse, half of it. All right. Not the full show, half the show. All right. So from here in the center to the left. Okay. So it's called the super blood red moon. Why super? Because super moon, because the moon is very close to the Earth. All right. Why red? All right. So the answer to that is the same question. Why is the total lunar eclipse red? Is the same question as why is the sunset and sunrise red? You know that sunset, sunrise color related to the lunar eclipse. So this question is same as so basically it's actually our Rayleigh scattering. It's called by Rayleigh scattering. I'll explain why is it. It's the same question as so why is the lunar eclipse red, sunset, sunrise red? It's the same question as why is the sky blue? The two parts of the same question because of Rayleigh scattering. So I'll explain later. So this scientist, Lord Rayleigh, his original name John William Strutt, right, in the 19th century, discovered Rayleigh scattering. Nothing to do with modern physics, quantum mechanics, classical physics, Rayleigh scattering. So Rayleigh scattering is like this. You see here, usually the light from the sun is of all wavelengths at equal intensity. So for the Rayleigh scattering, the blue wavelength, the short wavelength are scattered more. As the wavelength become longer and longer, the scattering become less, much less. So the short wavelength, the blue are scattered more. The long wavelength, red scattered less. So that's called Rayleigh scattering. That's why, all right, you find that here you have the sky is blue because of Rayleigh scattering, because it scattered the short wavelength more, and the sunset, sunrise is red because, let's say, imagine the left is the sun, center, the earth, right is the moon. Say somewhere at the North Pole of Earth, there's a scientist sitting there in his warm clothing, and the sunlight passes through that. So as the sunlight passes the thin atmosphere, mind you, the atmosphere thickness is only 100 kilometers, not very thin layer. The diameter of the Earth is 12,000 kilometers. How much is 100 kilometers compared to 12,000? So the thin layer of the air will pass through it, the light will from the sun pass through it, and as it passes through it, more and more of the short wavelength scattered out. And some of them scattered back to the Earth's surface. That's why you see the sky blue color. And as the light passes through more and more of the Earth's atmosphere, so more blue is being removed, so the light becomes richer and richer in red. So finally, after passing to the atmosphere of the Earth, then when it goes here, and remember, because of the atmosphere of the Earth, it acts as a kind of a lens, you know. This is glass, but in the case of the Earth, it's its atmosphere. It's a kind of lens. The lens will bend the light inwards, right? So bend the light inwards. So first of all, you have Rayleigh scattering to make the blue light scattered out, and what is left behind is richer and richer in red. And also the Earth's atmosphere as a lens to bend the light inwards to fall where? To the moon. If let's say, if the Earth do not have any atmosphere, let's say the Earth is like a moon, no atmosphere. Let's say no atmosphere on the Earth. Then during a total lunar eclipse, how would the moon look like? The moon will disappear totally from the sky. You cannot see the moon. Totally dark, cannot see the moon. But because the Earth has an atmosphere, bend the light in, that's why you have Rayleigh scattering and bending in red, blood red moon. That's why. So it's Rayleigh scattering that make the moon red in color. All right. So this is the thickness of the Earth atmosphere from one of the space shuttle missions. This is very thin layer of the Earth, and this is a sunrise. So it's about 100 kilometers thick only, the Earth's atmosphere. All right. So that's it. So basically, what we are seeing here on the moon is thousands and thousands of sunrises on the Earth. As the sunlight passes through the Earth's atmosphere, you have a sunrise and sunset, and the light from this sunrise, sunset color continue to move forward and fall on the moon. So we are actually seeing the effect of thousands of sunset and sunrise all around the Earth, circumference the Earth, fall on the moon, and come back to the Earth. So you are seeing sunsets and sunrise on the Earth, on the moon, coming back to the Earth. All right. So this is during the total lunar eclipse. I never see people present that. Imagine you're on the moon. Okay, you're on the Earth, you see the moon during eclipse like that, but you're on the moon. How does the total lunar eclipse, what happens? So basically, of course, the sun is behind. The size of the Earth is bigger than the size of the sun angular distance. So the Earth will totally block the sun. But because of this red scattering, the Rayleigh scattering, you see a thin atmosphere of the Earth, red color, bright red. And then this part of the red light of the Earth falls onto the moon. So at the total phase of the eclipse on the moon, this is how you see the Earth look like. Of course, here why is it dark? Because this is the Earth shadow. So this is the Earth as seen from the moon during the total phase of the eclipse. So again, you are seeing here from the moon. Look here, thousands of sunrise and sunset. Imagine this is in Hawaii. No, this is in, let's say, Chile, and this is in, say, let's say Romania. So this is a sunrise in Chile. This is a sunset in Romania. That like this, very nice, So basically, you are seeing thousands of sunset and sunrise around the world. The light falling on the moon and coming back to the Earth. All right. So now, how to observe the lunar eclipse from AIMST University? So as I said, the moon will rise at 7:27 p.m. in the eastern sky, azimuth 111 degrees, and it should be on the eastern side somewhere here, or even outside here, or even I check maybe somewhere here there may be some open space. All right, you can observe, and this is the information. So basically, it's coming here to here. So actually, from the center to here is the part we see. Let's look at the contact point. Remember, if you look at this part, they always have the contact points here. All right. So look at the contact point. So the one for us of any interest are, ladies and gentlemen, U3 and U4 only, between 7:25 and 8:52 only. Here, P1 to U3 we cannot see. All right. Then U4 to P4 we cannot not interesting to us. But let's look in detail. What are all these points? Huh? P1 and so on. Okay, so P1 means the moon touches the penumbra of the Earth. P1. All right. After that, what's that? U1. No, so no, 4:47, the eclipse occurred 4:47 p.m. The eclipse. U1 is, you look again, okay, 5:44. 5:54 means the moon touches the umbra of the Earth. 5:54. But then still not interesting. Then the more interesting thing is then is 7:11 p.m. Malaysian time is when the moon totally enters into the Earth's umbra. Total lunar eclipse begin. All right. So I repeat, total lunar eclipse begin at 7:11 and will end at 7:25 over a period of about 14 minutes and 30 seconds. But the greatest eclipse is at 7:19 p.m. So 7:19, the moon is right in the center. Right. So these are the past interesting. So it's about 14 and a half minutes only. So by the time at 7:25, sorry, ladies and gentlemen, the total phase of the eclipse will be over by 7:25. And you see the moon 7:27. Too late, right? But never mind. When it comes out of the umbra, it's still in the umbra, it's still worth observing. All right. So the word observing is still in the umbra 7:25 p.m. to 8:52 p.m. or roughly 7:30 to 9 p.m. So from 7:30 to 9 p.m., the moon will be moving from here, between here to out. So you see that the moon will be fully red, but as time passes by, more and more of the moon become brighter. But half of it become red. Then quarter of the moon still become red. Then 1/8 of the moon become red. And finally, all the moon become bright. That is a part worth seeing. So you take a picture of the moon, even half the moon is red, it's still worth observing. Right? So from 7:30 to 9 p.m. And we hope the value is clear. So at this time, ladies and gentlemen, the moon should be quite high in the sky. All right, you should be able to see it. So how to observe with it? There are many ways to observe. I can think of one of us called with your eyes. No. I thought you need to have special glasses to block the moon's light. No. It's not a total. It's not a solar eclipse. Dangerous. You look at the sun, can become blinded. No, the moonlight is what? The moonlight is from the sun passing by the Earth, fall on the moon, scatter back to the Earth. It's very not powerful. So it's safe to look at the lunar eclipse with your eyes, all right? Like this. Or with binoculars, a good one, because binoculars have magnification. Or with telescope. All right, so I understand 5 of your students are observing with telescope, but we hope, Dr. Hari, they will follow the SOP, all right?
Yeah.
And please tell them, don't take a group selfie. You can take
No.
a selfie. No, what I'm saying, you can take a selfie of you alone with the eclipse, but not as a group. Okay?
Okay, sure.
Yeah, this one was 2018. We have a lot of stargazing activity, car passing live every Saturday night, crazy. A lot of people join us. So this is a Newtonian telescope can observe. All right, 2018 car passing live. You can look at the eclipse. All right, and this is the Dobsonian telescope also can see. All right, and even the young gentlemen here can enjoy. But of course, they're looking up, vertically up. So you can observe with telescope. All right, and this girl here is using a star chart to observe. So when you look at the eclipse, it's not only at the moon. Where is Scorpio? So you use your star chart. Oh, this is Scorpio. Oh, next to Scorpio is Sagittarius. So you can learn the stars and constellations during the eclipse. All right. And this is my member, Mr. Lai. He's doing now a PhD in aerospace engineering in China, teaching them how to use the star chart. So later, maybe I'll pass to Professor Ravi Chandran a lot of star chart. Please pass it to your AIMST student. So star chart, you can learn the constellation. And you look at the moon, and you have a moon chart. You know that when we look at the moon, we also refer to the moon chart. So I say, oh, look at the moon. Oh, this is Sea of Tranquility where Apollo 11 landed. This is what Copernicus. So you must know the names of the features of the moon, all right? And this is taking picture of the eclipse. So you can take with handphone, iPad can take, all right, with a DSLR camera. And also you can put your handphone onto a kind of tripod and you can take picture of the eclipse, all right? And with this, you can take what? Time-lapse, all right, like this. Of course, you cannot see the whole thing. Half of it. Dr. Hari, please tell them half of it. And don't take blindly just an empty space. Some building, some landscape thing, okay? Or with a DSLR camera, time-lapse, better camera, And I think this is a picture of one of your building. I don't know where it's a library building. So you take
This is the library, yes.
library, yeah? And there you are, the moon rising. Wow, that would be nice. So try and see them. Do time-lapse also. All right. Take selfie. Don't take a good selfie of this daytime. Imagine at night, the moon is behind this girl at night. The moon is rising in eclipse. Take a picture of you and the moon. That would be great. Selfie. All right. All right. Or take someone to take a handphone. You and the moon, eclipse moon behind you. And the one is you have done before. The moon is small. You make your two fingers touch the whole the moon. Someone taking of your finger far away, and you're holding the eclipse moon, the blood red moon. Or even better, Dr. Hari, your mouth is opening. You're going to swallow the moon. Yeah, I've done it before. The moon. And like this, far away, take a picture. You are holding the moon. Oh, the eclipse moon. And of course, this line where the moon is right inside, in the center. That would be great. Take a picture of you in the picture with the eclipse moon, with the time-lapse. All right. So most important is must enjoy. So basically, so over the years, we have taken a lot of eclipse. Some of them have actually assembled the whole eclipse like that. Like that, I've done before. All right, taken in KL, Penang, all over Malaysia. Okay, on the power. Like this also got. Good job. Of course, it's not possible for all the moon to in a circle, but this is it. They arrange it like in a circle. All right. So now we have tonight, beginning at 7 p.m. already started. Live streaming from the Astronomical Society of Penang YouTube channel. This is it. All right. So please go in after this and observe. I hope that your students in AIMST will have a good time to take picture. If you have any problem, Dr. Hari, please you can ask me. All right. Okay. So then, so now near the end, got some more. Yes, of course. Remember the last total lunar eclipse, Professor Ravi Chandran, was 2 years ago, 2019, but not visible from Malaysia. Yeah, we were so angry. So this was after 2 years, 2019. Now they have a total lunar eclipse, but not seen from Malaysia, from Hawaii. So the next one seen from AIMST, total lunar is 8 November 2022. So total lunar eclipse, the whole eclipse can be seen. But this year, you can see a partial lunar eclipse. 19 November 2021 is what I was doing. So the 19 November 2021, later this year, is quite similar to tonight's eclipse. Half of it can be seen. But the full eclipse will be next year, all right, from AIMST. So now it's just a promote. I mentioned to Dr. Hari, my society also over the years got some product. So in Shopee, you can get this t-shirt. I love Astronomy unisex round neck full cotton t-shirt, different sizes. So we try to have a simple logo, all right. So many of our members have bought it, very nice. And Lazada also, we have our astronomical calendar, where every year my society have astro photography contest 2020. So the winning prizes, the winning entries for last year's contest were published in the 12 pictures in this calendar. Very nice. This was January, right? So maybe I hope that maybe some of your AIMST students can do some astro photo. I think the closing date is sometime in September this year. Take a picture, send it to the Facebook of the Astronomical Society of Penang, and then maybe you can participate in this competition. Okay. Okay. Thank you very much. Okay.
Thank you very much.
Yeah. So any question? Not too many.
Yes, Doctor, I have a question.
Sure, go ahead.
Doctor, my first question is, you have mentioned that the speed of the moon is 1,000 kilometer per second, is it?
Yeah, around the Earth.
Around the Earth. Okay, what about the speed of the Earth?
That's a good question.
Also,
so you see, that's why I say, Dr. Hari, in astronomy, Prof. Ravi Chandran just tell you that when you ask a question, two new questions will be posed. You answer the two questions, more questions. So I repeat, the moon rotates on its axis, not too fast, rotates the axis. The moon also orbits around the Earth. So the orbital speed of the moon around the Earth is 1 kilometer per second or 3,600 kilometers per hour. So now the Earth also rotates on its axis, right? Yes. Very fast. So the Earth and moon as a system also orbit the sun. I think the question you're asking is, what is the total system orbiting the sun? As I said earlier,
orbiting the sun, exactly.
30 kilometers per second.
Okay.
You and I now are traveling like a bullet. So next time you see any alien in space, I say, don't come and see me on Earth. I'm traveling at 30 kilometers per second, you know. A small bullet already so powerful. I'm say 60 kg, I'm powerful. Not over yet, Dr. Hari.
Yeah.
Our sun,
No.
the planets, the whole solar system is orbit the center of the Milky Way.
Yeah, that's right.
See, the solar system is situated at 30,000 light years from the center of the Milky Way.
Yeah.
So at that distance from the center of Milky Way, how fast is the solar system orbiting the center of Milky Way? Don't be scared, huh? The speed is 200 kilometers per second.
That means what we are seeing, all the stars are all history, right?
Yeah, history. So there's no end to it. But you know, the story is not over yet, Dr. Hari. Is our Milky Way is rotating, we said lah. Is our Milky Way stationary in space? No. Our Milky Way is also moving. You know, Dr. Hari,
Our Milky Way
has a neighbor called Andromeda Galaxy.
Andromeda, yes.
Andromeda Galaxy is here because Andromeda Galaxies are colliding, you know. But not tomorrow, don't worry. Andromeda and Milky Way will collide in a few billion years in the future.
In the future.
So question, what is the speed of Andromeda Galaxy and the Milky Way coming to each other? Faster than 200 kilometers per second. Not over yet. No, faster than the speed of the 200 kilometers per second. But the solar system orbiting the center of Milky Way. Is that all? No. The Milky Way and the solar and the Andromeda Galaxy will form a local group of galaxies, about 50 galaxies. So many galaxies are in the cluster, and they are as a group. Milky Way and Andromeda is part of this group, you know. So this group is called the local cluster of galaxy. So this local cluster of galaxy itself is rotating. So that speed also must be bigger. Is a bigger velocity. Is that all? You know, I can go on the whole night. Not yet over. That is, this cluster of 50 galaxy is here, and far away got another cluster of galaxy. You know, there are many clusters of galaxy, and these clusters are also opposing each other.
Multiverse.
And then this cluster, our cluster, and another cluster, let's say 1,000 clusters, form a what? A super cluster of galaxies, super cluster. And the super cluster also orbiting. And many super clusters will form a what? Super cluster. No end to it. That's why I said it's very crazy. So no end to it. Yeah.
Thank you, doctor. Thank you for your very wonderful.
So, Hari, you please tell your those students
Sure.
I know you're in Penang. Give them advice. Okay.
Thank you, Dr. Chong. We've been getting a lot of congratulatory messages from our audience on the chat, and they all thank you for such delightful and entertaining lecture. Obviously, you are very passionate about this subject, and you have kindled in us an interest in astronomy. We have one more question that is from Professor Bina Rai.
Yes.
And she says, thank you, Dr. Chong. We enjoyed your talk very much. And her question is, Dr. Chong, do you sell astronomical sky charts, as the one she got from USA in 1986 was excellent? It still is. And whether there's any update from the time that she had bought it in 1978. So do you sell astronomical sky charts, Dr. Chong, that we could possibly buy from you?
Thank you for your comment from the staff. Actually, star chart, sky chart, or something called like that, comes in various types, you know. The one I use is a simple one. So each one costs about 25 cents only. And on it, you have all the 88 constellation and the 5,000 stars. It's front and back. So it's a simple one, and it's good. But now, Professor Dato, do you know what we have the invention now? The handphone. In the handphone, yes, you can have many free apps. What I have here is Sky Map. Or you can have Sky Map, free one. And another one is digital pay, Sky Safari and so on. Sky Map is good. So if I install the Sky Map, you know what I do is, they have Android version, they have the Apple version. So I have a Sky Map, I put my GPS on, I put, hey, that's Leo constellation. And then I want to find an object which is not there. Let's say I want to see where's Mars. I tap on it, Mars, then there's an arrow pointing. There you are, Mars is there. So easy. So now, in the saying, Professor Ravi Chandran and Professor Dato, the star charts are now obsolete. It's all app. You use app, Sky Map, very nice. Do you know, Professor Dato, if I am a teacher in the kindergarten school, you know how I can motivate the kids? Daytime, I say, come here, this constellation is there. You cannot see it now, bright sky, but it's there. Then tonight I can show you another one. So nice, you know, right? So that's it. So you just put on the sky map. But if you want a bigger star chart, you can buy. I have in my office last time. Yeah, star chart which are 3 feet by 8 feet, no. 3 feet by 8 feet, but and colorful one. And some of these star charts are fluorescent. They glow in the dark. Wow, very nice. So in a sense, Professor Dato, I hope that
Yes, sir.
After tonight's event, we hope maybe your AIMST University can see which students interested. No need to involve many students, at least a core group of them to start some activity. And I also
Yes,
mentioned to Dr. Hari just now, why not you do something like a project, short-term project, or if let's say you feel it's required, maybe final year project on astrophysics, astronomy. I've been supervising many final year and one MSc student on astronomy. They all enjoy it like this. So we leave up of the too much theory, we go straight into the practical hands-on. That's why they're interested. Yes.
Fantastic.
Mr. Chairman, can I just have one word with Dr. Chong, please?
Yes.
This is Grace. I'm with the Faculty of Law, University of Malaya.
Yes.
Dr. Chong, I was just wondering, is it possible that even our law students might be, be encouraged to do a course in astronomy on the basis that it's one of the co-curricular courses? Will that be something that is feasible, please? Thank you.
It's a good question. Actually, I would say straight away that it is time that we do this kind of thing in Malaysia. For example, in Malaysia, in USM, for example, the student taking the School of Physics Astronomy courses are the physics student or the science student. But we know, Professor Ravi Chandran, that in America, many of the famous astronomers, they became famous as well. Their beginning was not in astronomy, they were in let's say arts, that BA. But as a BA student, Bachelor Arts student, you can take an option to do an introductory astronomy course. They don't have any prerequisite. They allow you to do. And when they do the course, they like it. Then they continue for their masters in astronomy and PhD. So in the American system, at the bachelor level, you without precondition, you can take astronomy course. And many of the famous astronomers in America began with that. The original one was not in physics, not in engineering, was in arts, in other fields, in biology. So we hope that we can bring it to Malaysia. That, for example, in USM, I taught this course before. There are 4 courses in USM, and we have a minor program in astronomy. So the first 2 courses I taught. So the first course don't have prerequisite. You can be from any department you can join. The only problem is some of the management students want to join, but the units in management school already full. So what do? They audit the course. They take a course without taking any credit, but because they like astronomy. But we hope that we can bring it to University Malaya and other universities that you are not a science student, but no prerequisite. As long as you're interested, you can take the course. But in this course, I will feel that please must include the practical component. How to use telescope, how to see star chart, and maybe once in a while, if you're in KL, take them on a trip to, let's say, to the jungle in Pahang, astrotourism, all right, to Morik, all right, to observe, all right. There's many amateur astronomers in KL. Do you know, ladies and gentlemen, that the sky, not only in KL, the sky in Klang Valley is gone. Too much light pollution. So the poor amateur astronomers in KL will go to Terengganu, Johor, other countries to take photo. But we in Penang, we still have some dark area. So coming back to the original question, I think we hope that in University Malaya, the non-science student, but the keen on astronomy should be allowed to do astronomy. Yeah.
That would be wonderful. Actually, we can actually introduce it as even a 2-credit course to allow our students. Yeah. Thank you very much, Dr. Chong. That's a fantastic idea as well. Thank you.
Dr. Chong, I think we have taken much of your time. We have everyone, I think, is rushing to go out.
I am going out to my house to see you.
Yeah, everyone is rushing to go out to the streets to catch a glimpse of the lunar eclipse. We want to thank you very much for the mind-boggling points that you have raised about the moon shooting at the speed of bullet. You introduced us to topics such as supermoon,
Yeah.
micro moon,
Yeah.
full flower moon, and these were things that I myself was totally ignorant of, but now I'm completely illuminated. We thank you for the delivery of your presentation with such gusto and passion that it has infected all of us, and I'm sure everyone in the audience and on the Facebook would definitely appreciate the hard work and the knowledge that you have shared with us this evening.
Yeah.
And we thank you so profoundly, and we thank you so much for the time and effort that you have taken to educate us on the wonders and beauty of this universe.
So
Thank
thank
you
you
so
very
much,
much,
Dr. Chong, and thank you, ladies and gentlemen, for joining us. We hope to have more such sessions with Dr. Chong in the months to come.
Yeah. So
So
it was
stay
an
tuned.
honor and a pleasure for me. And please, Professor Dato, if you have binoculars, please take it out. I
Okay,
go
sir.
binoculars to see. Very
Lovely,
nice.
sir.
There's no
Lovely.
sun in the sky, it's absolutely safe. So if
Lovely.
you see the moon with your eyes or with your binoculars, please pass it to your friends, your family to look at. Yes, sir. Yeah.
Lovely, sir. Lovely, sir. Thank you very much. And ladies and gentlemen, have a very nice evening
Thank
and
you.
enjoy the lunar eclipse while
Yes,
there is still time for us.
Yeah. So Dr. Hari, thanks for arranging the session. All right. Yeah.
Thank you,
Okay.
Doctor.
Yeah,
Thank
and
you.
we thank Dr. Hari and Professor Ravichandran for having organized this
So we'll keep
session.
in
We
touch.
hope our
Okay.
students
Yes.
in front of the library are
Yeah,
enjoying
yes,
themselves.
Yeah. So let me know how are they doing, Dr. Hari.
Yeah, Dr. Chong, maybe Mr. Raman, I think you are there, right?
Yes.
Maybe you can just say a few words. You're in the field now. Please unmute.
Yes, unmute, Mr. Raman.
He's in the mobile.
Yeah.
Please unmute it. Okay.
Hello.
Yes.
Good evening. Good evening. Our boys are here.
Go anything you see. Is the moon there?
Hey. Hi, Dr. Chang. Remember me?
Yeah.
You
Hey,
go here?
are you from Penang?
Yeah, I'm from Penang, but now I'm in Kedah.
No. Which school you study in Penang?
Which school? I was studying in Hengi.
Did you take part in our? Have you seen me in your school? I go to Hengi very often.
Yeah, I did, but I actually graduated like 4 years back.
Did you join the Hengi Astronomy? Astronomy club?
Yeah, Hengi. Hugo from Hengi.
Oh, Hugo. Hugo, you look different. You look so different.
Different, right?
So casual. Hey, Hugo, you are the best person to advise your lecturers and Dr. Hari how to do the altruism. So our Hugo is quite what I call expert in Hengi Astronomy Club. He should be able to. Please, Hugo, don't hold back. Help them. Okay.
Sure.
Biotechnology student, Prof.
Yeah.
Thank you.
Hugo.
Thank you.
Okay. Thank you, Dr. Chong. Thank you very much. Thank you, Prof. Ravi. Thank you, Dr. Hari. Thank you, Mr. Jaya. Thank you, Mr. Raman. Thank you for all those who joined us. You made the session even more exciting with your compliments and your questions.
What you
Have a
want to
good
see?
evening. Bye.
Bye-bye.
Okay.
Bye. Bye.
Bye-bye.
Okay.
Bye, everyone. Bye-bye.
Bye.
Yes.
I think we will live stream the YouTube.
Live stream. Go to live stream.
Yes.
I'm going to look at the live stream.
Yeah,
We'll do that,
and that's the Penang Astronomical Society,
Dr.
Dr.
Penang.
Chong. Eh?
Yeah. I'm going to watch now. Okay.
Okay, sir. Okay.
Thank you, sir.
Lovely, sir. Thank you very much.
Okay. Bye-bye.
Bye. Good night.
Good night.
Good night.
Good night.